Okay, we wanted the solutions to the previous problems. In problem 1, the last digit of, in the ones place, of a 5-digit number, 14,700, to divide by 2. The last digit is 0, 2, 4, 6, or 8. Dividing by 3, the last digit can be 0, 3, 6, or 9. I'm going a little bit fast, you can check your answers. Divisibility by 4, the last digit is 2 or 6. Divisibility by 5, the last digit is 0 or 5. Divisibility by 6, the last digit is either 0 or 6. Divisible by 8, the last digit, the ones digit must be 6. Okay, sorry if I go fast. 9, the last digit must be 3. 10, the last digit is 0. And 11, which was optional, if you have it, it cannot be done with the numbers I have. Then we wanted the least common multiple of 594 and 6,532. So I do a prime factorization, and when you're finished with the prime factorization, you're supposed to get, I guess I can let you look at that quickly. You get a 2, a 2, a 2, a 3, a 3, and over here you are down to 91, so you get a 7. You have a 2, a 3, a second 3, a third 3, and over here you get an 11. So in columns, 2, 2, 2, 3, 3, 3, 7, 11, 13. And when you multiply all of these, you're supposed to get 216,216. It's a coincidence that both of these parts are the same. Both of these periods are the same. Okay? It's a coincidence. Okay. So if you multiply this together, 216,216. Did you get that? Do we agree? If I make a mistake, please let me know. And I do make mistakes. You're a chef at a restaurant, you are free every 6th day, your spouse is free every 8th day. When do you meet again? What's the least common multiple of these? It is 24. So you meet again 24 days later. Today was July 1st, so that'll be July 25. And here's a check. I hope you did not do it this way to get the answer. The trick was least common multiple. And then, now here, we wanted to find 3 fractions equivalent to 8 over 11. And the denominator is to be less than 35. So multiply by 2 over 2 to get 16 over 22. Multiply by 3 over 3 to get 24 over 33. And multiply by 4 over 4 to get 32 over 44. I let you copy that. So I have 11 over 20, I have 16 over 22, 24 over 33, and 32 over 44. Are you with me? I'll go on. We wanted to reduce 630 divided by 1,764. So I do a prime factorization, or actually I see what I can divide by. I realized this was 9 times 70, 9 times 196. Factor out 9 over 9, you're left with 70 over 196. 2 times 35, 2 times 98, you're left with 35 over 98. Oops, am I going too fast? So first divide out 9, you're left with 70 over 196. Then 2 times 35, 2 times 98, so 35 over 98, which can be written as 7 times 5 over 7 times 14. You factor out 1, which is 7 over 7, you're left with 5 over 14. So exercise 2, 5 over 14. Then find the units digit such that this 5-digit number can be divided by 2. So the last digit is 0, the last digit can be 2, the last digit can be 4, the last digit can be 6 or 8 for divisibility by 2. And then find the units digit for divisibility by 3. The sum of the digits is supposed to be 21. So 21 plus the digit in the ones position, and that is supposed to be divisible by 3. So D can be 0, D can be 3, or 6, or 9. So 0, 3, 6, or 9. Did you get that? Hey, you got it! Wonderful! If possible, construct a number that is divisible by all of the following. Divide by 2, 3, 4, 5, 6, 7, 8, 9, and 10. What is the smallest such number? I'm asking for the smallest number because if you multiply all these together, you have a number that you can divide by each of these. Now, the number must be divisible by 5, 7, and 8, and 9. If the number is divisible by 8, it's also divisible by 4, and it's divisible by 2, so you don't need to worry about the 2 and the 4. If the number is divisible by 8, it's also divisible by 3. We don't need to worry about the 3. And if the number is divisible by both 2 and 3, it's also divisible by 6. So don't worry about the 6. So the number is 5 times 7 times 8 times 9, which I came out with as 2,520. Did you agree with that? Let me know. Okay, 2 people agree with me. What about the rest of you? Now, n can be any multiple of that, but it's not going to be the smallest number that can be divided by all of these. So there are infinitely many numbers that you can divide by all of these. But the smallest one, if my arithmetic is right, 2,520. Reduce. Instead of doing a prime factorization, because I'm limited for space here, I wrote 14 as 2 times 7. Oh, I did a prime factorization. So my prime factorization is 1, 2, 3 2's. Most people write it as 2 cubed. 3 times 3, 7 times 7 times 7, over 2 times 2 times 2, times 3 times 5, 7, 7, 11. You want to copy that? Wouldn't it be nice if you had the PDF already? You can get it. You can send me an email, hfeiner@coastline.edu. Okay. You can factor out 1, 1, 1, 1, 1, 1, and you are left with 3 times 7 over 5 times 11, or 21 over 55. How's that? Can I go on? What is a prime factorization of 264? I made a compacted tree. What do I mean by that? This is 2 times something. The 132 is 2 times something. The 66 is 2 times something. The 33 is 3 times something. And I'm down to just prime numbers. So it looks like 2 cubed times 3 times 11. I'll do the same thing with 495. I realize I have 3 times this number. 3 goes in here again, that's 55. 55 is 5 times 11. So that's 3 squared times 5 times 11. Now, you have that. We're going to put it in nice columns. and we are going to get the least common multiple of 264 and 495. There we go. 2, 2, 2, only 2's here, 2's here, 2's here, 3's here, 3's here, 5's here, 11's here. So the least common multiple seems to be 3,960. Okay. Now, compare those two fractions, 5 over 264 and 7 over 495. Most people teach you cross multiply and see which of the two numbers is the bigger one, that's the bigger fraction. You're encouraged to cross multiply, so you get 5 times 495, 7 times 264, and the 2400 is a bigger one, so that's a bigger fraction. Now, let's revisit this comparison. We found the LCD to be 3,960. Note from the array above that 264 needs to be multiplied by 50 to get that number, and 495 needs to be multiplied by 8 to get the same number, the least common multiple. And so I discovered I multiplied by 15 over 15 to get this number right here, the denominator 3,960, multiplied by 8 over 8 to get the same. We have the same denominator, now compare the numerator. 75 is greater than 56. 5 over 264 is greater than 7 over 495. That's another way of doing it, and that makes sense. There's a justification here, rather than cross-multiply. Who says cross-multiply? Why can you cross-multiply? Just because somebody tells you? Did they tell you correctly? Okay, we are revisiting that. And then we wanted to reduce something again. So I have two reductions here. Okay, so I did a prime factorization. 2 times 2 times 3 times 3 times 7, 2 times 5, 11. 5 times 7, 2 times 2, 3 times 3, 2 times 13. I can reduce as follows. I should be left with just an 11, and I should be left with just a 13. Would you like to copy that? Okay, I'll go on. Convert 150 over 37 to a mixed number. Well, we divide. And 37 goes into 150 4 times with a remainder of 2. So 4 and 2 over 37. Convert 7 and 9 over 28 to an improper fraction. The quick way, 7 times 28 plus 9. So 7 times 28 plus 9, which is supposed to be 205 over 28. Yes? No? Maybe? I can go on. Oh, that's the end of this one. For the next set, that's my chapter 9, solutions to the exercises. What is the prime factorization of 264? 2 cubed times 3 times 11. What is the prime factorization of 495? 3 squared times 5 times 11. What's the least common multiple of those two? You have 2 times 2 times 2, 3 times 3, 5 times 11, or 3,960. You want to add those two fractions. You have to multiply the first fraction by 15 over 15, the next one by 8 over 8. You get 75 and 56 over 3,960. Haven't we seen these numbers before? Which gives you 131 over 3,960. This is a multiplication. This is a multiplication. There's not much of a gap between the two fractions, but I should have left more of a gap. Okay. Can we reduce this? Well, what goes in here? 2, no. 3, no. 5, no. 7, no. 11, no. And once I'm beyond 11, I don't need to worry about anything else, because 11 times 11 is almost as big as 131. We'll get into that later. Now, mother has 5/6 yards of a cloth, and she wants to make napkins. They require 9 inches of cloth each. How many napkins can she make? Well, the first thing we want to do is we want to get common units. 9 inches is how many yards? A quarter of a yard. How did I get that? 9 inches times 1 foot per 12 inches. The inches drop out. Inches over inches is like 7 over 7. That is 1. I'm left with 9 feet over 12. The inches are gone. And I want to multiply that by yards per foot. There are 3 feet in the yard. The feet drop out. 3 over 3 is 1. You get 1/4. 9 inches is 1/4 of a yard. And we want to take away 1/4 and another 1/4 and another 1/4. What is repeated subtraction? You're right. It is division. So we are going to divide the total number of yards by yard per napkin. And we want to divide that. So when I divide by a fraction, I multiply by the reciprocal. I had warned you that you might need that. And the units are now yards over yards, which drops out. So you know you've done it correctly. Here you would get yards square per napkin. That would not be right in the multiplication. If you multiply by the reciprocal, the yards drop out. You're left with 5. The 2 drops out here. You're left with 5 times 2 over 3. Or just 3 napkins. And you have 1/3 of a yard left. Just 3 napkins. Not too many, but that's the way it goes. I could have done it the other way. I could have converted to inches instead of yards, redo the problem, and I come out with 3 also, and I'm left with 3 inches. Would you like to see this? If you want to copy it, be my guest. You can do it either way. Either work with yards or work with inches, but be consistent. Don't mix the yards and the inches. I'll do number 6 now. I think number 6 was a real interesting one. If you got that right, you can really be proud of yourselves. Okay. A warehouse contains a certain number of boxes, all of the same size. 2 over 21 of these boxes are removed on Monday. 1/6 of the remaining boxes shipped on Tuesday. 1/2 of what is left on Tuesday goes out on Wednesday. And finally, on Thursday, all of the remaining 190 boxes are sold. How many boxes were there originally? Ooh. Well, as I gave you a hint earlier, I have the number in this box. Call it the X box. So I have to divide that box into 21 parts, 6 of which or 2 of these I remove, and I'm left with 19 over 21 of the original boxes. On Tuesday, 1/6 of that gets removed. So That's 1/6 of 19 over 21. That means 19 over 26 gets shipped out. 19 over 126 of the original boxes goes out. Okay, that goes out. When you subtract the 2 with a common denominator of 126, you're supposed to be left with 95 over 126 of the original number, which we don't know yet. And that's on. Then half of those are sold on Wednesday. So half of that is 95 over 252. We have to remove that, or that is what is left. We remove that and we are left with the other half. The other half is 95 over 252. And that, we are told, is 504. Okay? So now we have to work out what x is. And how did I find x? I said x was 252 over 95 times 190, which gave me 504. And as I said, if you get that, you're exceptional. And then I wanted to check and see if this works. So if we had originally 500, here I show you a quick way of doing it. I'm repeating what I had done. I show it to you in a compact form. Number of boxes left on Monday, number of boxes left on Tuesday, number of boxes left, that should be Wednesday probably. No, that's what I've left on Tuesday. So this is what I sold on Wednesday. This is what I've left on Wednesday. So first you sell and then you remove. And this is this is the fraction I have left on Thursday. So the fraction times what I'm after is 190. So multiply both sides by the reciprocal, the 252 over 95, and you get your 504. And then I wanted to see if that really works. On Monday I took 220 over 21 of 504, 48 boxes went out. I am left with 456 for Tuesday. On Tuesday, 1/6 of that goes out, so 76 boxes goes out. Subtract that from what you have left, you have 380 boxes left. 1/2 of that goes out on Wednesday, so 190 goes out on Wednesday. Subtract from the 380 that you had on the previous day, you're left with 190. Just like we said, you're left with 190. Wasn't that a fabulous problem? Ooh, I love these problems. I can already hear it. Don't give me a word problem, I can't do it. It's more difficult, I grant you that. Can I do all the word problems? No. Do I have trouble with word problems? Yes. But when you do a lot of those, you get the hang of it. Does this problem whet your appetite? This one? Okay, we want to subtract 2 over 1,155 from 5 over 42. Well, we want to get the common denominator, preferably the least common denominator. Do a prime factorization of 42 and 1155, and you should get 2 times 3 times 5 times 7 times 11, which is supposed to be 2,310. I'll keep that up for a little while. Okay, so 5 over 42 I multiply by 55 over 55 to get that denominator. This one I multiply by 2 over 2. I have the same denominator. I can add the numerators, which gives me 279 over 2,310, which cannot be reduced. Why? Because 2 doesn't go, 3 doesn't go, 5 doesn't go, 7 doesn't go, and what else? 11, I think we have an 11. That doesn't go in here. That's it. You need to work with only the prime numbers that are factors of the denominator. If none of those go in the numerator, you're done, unless the denominator is a multiple of the numerator. So if the denominator was 7 times 279, you could divide by 279. Okay, can I go on? We had another reduction problem. You do a prime factorization, and you come up with 11 over 13. And then we had the rope problem. You go to camp with a long rope, 45 2/3 feet, and you need to cut it into 1 3/4 feet, because each scout is going to get that part of the rope. Now, after we cut, we have exactly enough pieces of rope for each scout. So how many scouts are in the troop? How many pieces of rope can you make? So you take away one piece of rope, a second piece of rope, a third piece of rope. Repeated subtraction, division. You divide 45 2/3 by 1 3/4. And the rope can be cut into the division. The first thing I do is I need to make this a improper fraction. So 3 times 45 plus 2, that's supposed to be what did I do here? Oh, this has nothing to do with this. This is 45 times 3 plus 2, that's 137. This one is 4 times 1 plus 3, or 7 over 4. Divide by that, so multiply by the reciprocal. Note the units. The feet drop out, you're left with the scouts. You wanted to know how many scouts. And apparently, this is 137 times 4 over 3 times 7. 21 into 548, which apparently gives you 26 and 2 over 21. You had this many pieces of rope. Each scout got 1, so there were 26 scouts. You are left with a little bit of rope that you can't use. Should you see those numbers again? 137 over 3 divided by 7 over 4. So 137 over 3 times 4 over 7, which should give you 548 over 21, or 26 and a proper fraction. How was that one? A practical problem? Convert 150 over 37 to a mixed number. Well, divide 37 into 150, and you get 4 and 2 over 37. Convert 7 and 9 over 28 to an improper fraction. 28 times 7 plus 9 is 196 plus 9, or 205 over 28. Something tells me I've seen these examples before. Add 25, 6 over 7 to 12, and 11 over 14. Maybe that's because just this morning I shot the problem. I gave it to you this morning, and I'm doing the solution now. So do the proper fractions by themselves. Get a common denominator, which is 14. You have 12 over 14 plus 11 over 14. You just work with the fractions. And once you're finished with the fractions, you reconvert this 23 over 14 to a mixed number. That's 1 whole and 9 over 14. Positive 9 over 14, okay? Not negative. The fractions here get replaced by 1 and 9 over 14. And when you add these two, you get 37, and that should be plus 1. So the answer is 38 and 9 over 14. Why plus 1? Because you get a whole number 1 right here. Does that make sense? Do a subtraction. First try to subtract the fractions. 11 from 9 is a negative number. So go back and redo that. Rewrite the 38 I do okay, I see what I'm doing. I didn't go back and borrow from the 38. I have to subtract the 12 and the 11 from the 9. I do the subtraction. A negative number plus a positive number is a negative number. I don't remember if we've already done that or not. If not, drop this and go back and borrow. Make it 37 and 14 over 14 plus 9 over 14 and subtract from that. I will continue with a negative number. So subtracting 12 from 38 gives you positive 26. You had a negative 2 over 14. That's not a proper, that's not a mixed number. Mixed number is a whole number plus a positive proper fraction. So at this point, I am borrowing, and I'm writing this as 14 over 14. Same denominator, 14 minus 2 is 12. So 25 and 12 over 14, or reducing, 25 and 6 over 7. Did I go a little bit fast again? So I'm at this stage, 22 and the negative number. That's 25 plus 1, which is 14 over 14. Two fractions with the same denominator. I add, in this case I add a negative number, really subtracting. 14 minus 2 is 12, 12 over 14, so 25 and 6 over 7. We want to estimate. We got something close to 9, close to 4, close to 7. So 9 plus 4 minus 7, about 6. And take a breather. This is chapter 10. We do multiplication and division of fractions. Every chapter is a section in somebody's book, like our author's book. And as I said before, you can get the PDF, that is the printout for these lectures. And you can get them by sending me an email at hfiner@coastline.edu, or have somebody mail it, and I can return the book by return email. If you find a mistake or a misprint, please let me know so I can correct it in the next edition. We are doing section 2.4 in AST, which is multiplying and dividing fractions. Then we are doing my next chapter, chapter 11, I think, which is section 3.1, Introduction to Decimals in AST, and then adding and subtracting decimals. So let's get started with the basics. Since 1 is the identity for multiplication, any number, including a fraction, times 1 is that number. 1/2 is 1/2 times 1. 1 can be written as 2 over 2, and 2 times 1 is 2, and 2 times 2 is 4. So 2 over 4 is also 1 over 2. We had seen that before, hadn't we? Multiply 1/2 by 4 over 4, get 4 over 8. Multiply 1/2 by 3 over 3, get 3 over 6. Multiply by 5 over 5, get 5 over 10. That's pretty decent, isn't it? So the numerator and the denominator of any fraction can be multiplied by the same number. You're just multiplying by 1. And you get equivalent fractions. And the number 0 is kind of unique. 0 times any number is 0. Again, including a fraction. 0 times a fraction is 0. The process works in reverse. That is called reducing fractions or simplifying fractions. 2 over 4 can be written as 1 times 2 over 2 times 2. 2 over 2 is 1. 1/2 times 1 is 1/2. 3 over 6 is 1/2 times 1, which gives you 1/2. 4 over 8 is 1 times 4 over 2 times 4. The 1 drops out, you're left with 1/2. 5 over 10, 5 over 5 is 1, you're left with 1/2. Okay? These examples illustrate the fact that the numerator and the denominator of any fraction can be divided by the same number. Previously we said multiply, now we said divided. But be careful, that works only with factors. Factors, multiplication, multiplication, multiplication. Not addition. This 3 and that 9 cannot become 1 over 3. You cannot cancel. Oh, I hate that word cancel. You cannot reduce because you don't have multiplication. If you allowed that, you would get 1 plus 6, 7 over 3, which is 2 and a third, and you started with 1. 1 is not the same as 2 and 1/3, so something went wrong. That should be a 1/3, not a 1/2. Okay? So go ahead, send me an email about that so I can correct it. I don't take any notes. Not while I talk here. Again, be careful about the word cancel. People can cancel the 2, but they make a mistake in canceling. I would prefer you say factor out the 1 in the form of 3 over 3 or 4 over 4 or 99 over 99, whatever it is. Stay away from that word cancel. Now, you could factor out a 3. You get 3 times 1 plus 2, 3 times all this, just like 3 times the 3 in the denominator. This 3 over 3 is 1. 1 times 1 plus 2 over 3. You factored out a 1. That gives you 3 over 3 times 1, which is 1. You start with 1, you end up with 1. So what you did here was correct. Because all was multiplication, not addition. Excuse me. Not addition or subtraction. Addition, multiplication. Okay. This addition gets transformed into a multiplication by factoring out a 3, by using distributive property backwards. Okay. If possible, always reduce fractions given as answers. Okay? Always, always, always reduce fractions if you can. Now, visibility tests come in handy. You wanted to reduce 2 over 35 times 18 over 11 times 12 over 49 times 455 over 432. Now, I can see some people grabbing a calculator, multiplying those 4 numbers in the numerator, those 4 numbers in the denominator, and then scratching their head. How do I reduce that? Well, it's very simple. Reduce, if possible, before you multiply. So I've taken the 35, made it a 5 times 7, and I had a 5 times 91 here, which was 455. I do this one step at a time because I'm limited for space. So I get rid of the 5, I factor out 5 over 5, which is 1. I'm left with 2 over 7, the 5 is gone, and 91. And I'll write that as 4 times 108, that's 432, and this 12 as 4 times 3. 4 over 4 gets factored out as a 1. I am left with 2 times 18, which is 9 times 2, over 349. 108 is 9 times 12. 9 over 9 is factored out. I am left with 2 over 7, and so on. 7 here, factored out. I am left with 2 times 2 times 3, 2 times 2 times 3, which I can get rid of very quickly. And I am just left with 13 over 11 times 49, which is 13 over 539. Okay, that was a little fast. Should we go through that again? I can factor out a 5. You can do this in a different order. Okay, the result will be the same. So I factored out a 5 over 5, then a 4 over 4, then a 9 over 9, then a 7 over 7, then a 12 over 12, and that left me with 13 over 539. Okay? Multiplication of fractions. The following is an illustration showing multiplication. It's not a proof, but something you can sink your teeth in. You start with an original whole, which is the entire pie, and you take 1/4 of that. This is 1/4 of this whole. Now, never mind where this came from. Assume this is your whole, and this whole gets divided into 3 parts. 1, 2, 3. So one of these parts is 1/3 of this whole, and the same pie, forgive me, I was not able to put a circular arc here, I have a straight line here. So this little circular arc is that circular arc, which is also this circular arc. I am back to the original whole. Remember, I had 4 pieces, which I divide into 3 each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This little piece is 1/12 of the whole. It is also 1/4 of 1/3 of the whole. So 1/3 of 1/4 is 1 over 12. 1/3 of means multiplication. 1/4 is 1 over 12. Do you see 1 times 1 is 1 and 3 times 4 is 12? That suggests that in order to multiply fractions, you can multiply the 2 numerators and the 2 denominators. But before that, try to reduce if possible. Okay? We didn't get involved with reduction here. This was just a simple illustration of why you may be able to multiply 2 numerators and 2 denominators when you multiply 2 fractions. Okay? How do we divide fractions? Well, suppose we have 2/3 divided by 5 over 7. 2/3 divided by 5 over 7. I write my division frequently as a fraction. And so this is written as a ratio. And suppose we remember that 7 over 7 over 5 is 1. And we multiply this original fraction, 2/3 divided by 5/7, by 7 over 5 divided by 7 over 5. Like I am doing right here. Okay, what's the denominator? 5 times 7 over 7 times 5. 5 over 5, 7 over 7 is 1. You got 2/3 times 7 over 5, which is, as I said, 2/3 times 7 over 5. The 1 is not needed. Now, what happened? You divided originally by 5 over 7, which you transformed into multiplication of the reciprocal of the 5 over 7. This illustrates that division by a fraction, not of a fraction, by a fraction, the fraction in the denominator, the fraction you divide by, is equivalent to multiplication by the reciprocal of the original divisor, the original denominator. So A over B divided by C over D is equal to the same A over B times the reciprocal of the C over D, so the D over C. So AD over BC. Reciprocal, remember that one is the identity for multiplication. If AB is equal to 1, A and B are reciprocals. I already used the term reciprocal. Some students, or maybe many students, refer to the reciprocal as flip. Oh, I love those students. They make up their own mathematical terms. Well, it works. Okay, who can argue with that? So when you flip a fraction, you have the reverse. The reciprocal of 2 over 3 is 3 over 2. 1 over 2 over 3 is 1 times 3 over 2. As long as the denominator is not 0. So 0 is a number that does not have a reciprocal. What's the reciprocal of 5? It's 1 over 5. Because when you multiply the number by its reciprocal, you must get the identity for multiplication. Okay? 5 times 1 over 5. 5 is like 5 over 1. You get 5 over 5, which is 1. That was example 1. Example 2. Which natural number is its own reciprocal? Natural number, what were natural numbers again? 1, 2, 3, 4, and so on. Not including 0, that would be whole numbers. So what's the reciprocal of 1? It's 1 itself. 1 is its own reciprocal. And example 3, which whole number does not have a reciprocal? Well, we have a solution. It is 0. And be careful. Suppose you are asked as a homework problem, write the reciprocal of 3. Well, that's 1/3. What is my warning here? Oh, 1 over 0 is undefined. Okay? 1 over 0 is undefined. 0 over any number is 1, but 1 over 0, no, 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 no. Suppose you were asked in the homework to write the reciprocal of 1/3. You give the answer as 3 is 1/3. In your mind, you read the reciprocal of 3 is 1/3, but you state 3 is 1/3. Obviously, 3 is not 1/3, so be careful how you write that. If you write the whole sentence, 1/3 is a reciprocal of 3, that's okay, but not 1/3 equals 3. Okay, mixed numbers, I thought we had that before. A mixed number is a mixed up number. That's my own term, mixed up. It cannot decide whether it is an improper fraction or a whole number. It is a whole number added to a proper positive fraction with the addition sign omitted. So you have a whole number and you have a positive proper fraction, fraction less than 1. And there's an and sign in between. So that's a mixed number. Whole number plus a proper fraction. This is an example of a proper fraction. This is 14 over 15. The denominator is more than the numerator. This is an example of a mixed number. 1 whole and 5 twelfths. 1 whole and, there's a plus here, which people don't write. But in this case, the and means addition. And does not always mean addition. Here it does. Here is how we convert an improper fraction to a mixed number. Divide the numerator of an improper fraction by its denominator. The quotient is a whole number. The remainder is the numerator of the proper fraction. Divide 41 by 12. 12 goes into 41 3 times. We have a remainder of 5. 3 and 5 over 12. Can you reduce this? No. Okay. Then we wanted to convert 5 over 4/7 to an improper fraction. Okay. 5 plus, write that as 5 over 1, plus 4 over 7. You need the same denominator, which is 7, so multiply the 5 by 7 over 7. Now you have the same denominator. The numerators 35 and 4 can be added, which gives you 39 over 7. Okay? So 5 and 4 over 7 is 39 over 7. All right. You can read about all of that. How much time do you need? I hope not too much. The shortcut is, this is how they teach you, 7 times 5 is 35, plus 4 is 39. 7 times 5 plus 4, 39 over 7. I gave you the explanation why it works. Now let's do some arithmetic with mixed numbers. multiplication of mixed numbers. You want to convert the mixed numbers to improper fractions first. 3 times 3, 9, plus 1, 10. So 10 over 3. 5 times 7, 35, 39. 39 over 5. You multiply the 2. As a matter of fact, why don't you reduce? 5 goes into 10 twice. This is our multiplication. 3 goes into 13 13 times. Now, isn't that simpler? 5 over 5 drops out, 3 over 3 drops out. Without much work, you are left with 2 times 13, I think. Yes, 2 times 13, which is 26. So try not to multiply these two numbers. Before you know, you cannot reduce. Once you're finished with your reduction, multiply. Division of mixed numbers, well, that's pretty quick. If I divide by a fraction, I convert to improper fractions like I have done here. When I divide by mixed number, I mean. So I get 10 over 3 divided by 39 over 5. We divide by a fraction, we multiply by the reciprocal of that fraction. Can I reduce? No, I can't. So I get 10 times 5, 50 over 3 times 39. 117. How do I know I can't reduce? Only 5 and 2 is in the numerator. There's no 5 or 2 as a factor in the denominator. I don't need to worry about 3. I don't need to worry about 13. I'll leave this up for a few seconds. Yeah, I know I can go on. Thank you. Okay. Are we all done? That looks like it. No objection to going on. Complex fractions. What is a complex fraction? You've heard of complex numbers. This has nothing to do with complex numbers. A complex fraction is a fraction whose numerator and or denominator is a fraction. The numerator is a fraction, actually two fractions. The denominator has fractions, let's put it that way. The numerator and or the denominator have fractions. Then you have a complex fraction. How can we simplify a complex fraction? Some people teach you subtract the two fractions in the numerator, get one fraction. Subtract the two fractions in the denominator, get one fraction. Then multiply the one fraction in the numerator by the reciprocal of the one fraction in the denominator. You can't do that. Especially if you like fractions. Be my guest. I don't like fractions. I'll show you another way. Okay, one method. Oh, I'm showing you my way immediately. Okay, my way immediately. I have 1/2 minus 3 over 5 divided by 1 over 4 minus 9 over 25. I want to find the least common denominator of all the denominators, 2, 5, 4, and 25, which is 100. So I multiply numerator and denominator by 100, which is really 100 over 1. I distribute the 100 in the numerator. I distribute the 100 in the denominator. That gives me 1 times 100 over 2, 3 times 100 over 2, 1 times 100 over 4, 9 times 100 over 25. And all the fractions should be done at this point, because 2 goes into 25 50 times, 5 goes into 120 times, and 20 times 3 is 60. 4 goes into 125 times, 25 goes into 104 times, and 4 times 9 is 36. So 10 over 11. And again, don't confuse complex fractions with complex numbers that you'll hear about later. Okay, we are moving on. We want division as multiplication. Define division as multiplication. If you have 12 divided by 3, which is 4, you multiply the 3 by the 4, and you get your numerator or dividend, which is 12. So denominator times quotient gives you numerator. numerator over denominator is quotient. Denominator times quotient equals numerator. What is 0 divided by 5? Multiply the 5 by 0, you get 0. 5 times this 0 gives you that 0. What is 7 divided by 0? Well, let's put the number in a box. 0 times a box must give you 7. 0 times a box must give you 7. But that's impossible. 0 times any number is always 0. So 7 will never be equal to 0 times some number. What is the number in the box? There is no such number in the box. This number does not exist. That means that division by 0 is undefined. Be careful. I said division by 0 is undefined. I did not say 0 is undefined. Although some of you may wish that 0 were undefined, because if you get a 0 on the test, you know what it means, and you'd rather not know what it means. Well, too bad. Don't get zeros on tests. Again, I'm showing you what here? How to convert this into this improper fraction into a mixed number. We had done that before. Oh, I want to show you that if you multiply the denominator by the quotient, the denominator times the quotient, you get the following, which is 20 plus 3 or 23. You're supposed to get 23, and you do get 23. So I multiplied the denominator by the quotient, which gave me the numerator. You need to look at that. Okay, I'll go on. Again, it would be helpful if you had the PDF in print. You could follow this, you could make some notes, rather than trying to copy whatever I tell you here. Although 1 is not the identity for division, any other number can be divided by 1, like 4 over 1 is 4. Any number over 1 is that number. That's what I'm trying to tell you, I think. Okay, we do some exercises. Find the reciprocal of 2 over 5. Find 3 fractions that are equivalent to 2 over 7. Reduce 14 over 35 multiplied by 36 over 77 multiplied by 49 over 24. Then exercise 4, reduce 12 plus 18 over 3 times 2, 3 plus 2, 12 plus 18, all that over 3 plus 2. Reduce the following: brackets divided by brackets. In the first set of brackets, you have 12 over 35 times 21 over 4. So 12 over 35 multiplied by 21 over 4, which is divided by the second bracket. And in the second bracket, you have 9 over 10 multiplied by 26 over 11. 9 over 10 times 26 over 11. And then you wanted to find the product of the mixed numbers, 6 and 2 over 3 times 5 and 1/2. Working with fractions and mixed numbers is very, very important. Then find the quotient of 6 and 2/3 divided by 9 and 1/3. 6 and 2/3, all that divided by 9 and 1/3. So find the quotient, divide. Then simplify the fraction complex fraction with the numerator 1 over 3 minus 1 over 7. Numerator 1 over 3 minus 1 over 7. Denominator 1 over 9 minus 1 over 49. 1 over 9 minus 1 over 49. And then evaluate a squared plus 5b over a minus 3b. A squared plus 5b, all that divided by a minus 36. Divided by a minus 36. No, I'm sorry, that's a b. A squared plus 5b over a minus 3b, where a is 21 and b is 7. Okay, this is 5b and 3b, not 56 and 36. So a is 21, b is 7. And I'll show you next time the answers. Okay, Chapter 11, Introduction to Decimals. Basic terminology. You've heard of decimals before. Remember creating boxes of a particular type. Rewrite using as powers of 10. Like a trillion is 10 to the 12, a billion is 10 to the 9, a million is 10 to the 6, 1,000 is 10 to the 4, then divide by 10, you get 100, that's 10, correction, 10 to the 3 is 1,000, divide by 10, you have 10 to the 2, which is 100, 10 to the 1, which is 10, 10 to the 0, which is 1. Note the exponent, 6, 5, 4, 3, 2, 1, 0. Okay, and okay, you keep on dividing by 10 to go from the left on down. Can you keep on dividing by 10? Yes, certainly. If you get 1 here, you can divide that by 10. That gives you 1 over 10. Can you divide 1 over 10 by 10? Yes, that gives you 1 over 100. Can you divide, and so on and so on. So keep on dividing. So you got 10 to the 2, 10 to the 1, 1 over 10, 1 over 100, 1 over 1,000, 1 over 10,000. This is called a tenth with the th. Okay? Tenth with the th. Hundredths with the th. Thousandths with the th. 10,000ths with the th. Now, we run into a slight problem. We want to indicate that the 2 is in the 10th place, 10th with a th. How do we do that? Right now, the 2 is in the 1/10,100th place, 100, not hundredths with the th. I want to see, I need something. So how do I do it? I put in a decimal point. The decimal point is always placed between the 1 and the 10th with the th. So the first digit to the left is the 1 position, the first digit to the right is the 10th place, 10th with the th, 10th with the th. So 3 is hundredths, 4 is thousandths. In writing this, first we would have said 1, so write the number before the decimal point. Decimal point stands for and, 1 and. Cover up the decimal point and everything before, you read 232. Never mind about decimal point and so on. 234. But 234 what? 234, what is the position of the 4? Tenths, hundredths, thousandths. 1 and 234 thousandths with the th. We have 7 minutes left. Why doesn't this go on now? Okay. So 12.34 have the same meaning. The zeros here have no effect. The 0 in the front of the decimal point has no effect. But the 0 here is important, because with the 0 you get 12 and 34 10/100,000, and without the 0 you would have 34 hundredths. Okay, examples. Write this in words: 247 and 9 10/100ths. 247 with a hyphen between the teens and the ones, and for the decimal point, 9, okay, you read 9, and that's in the second place, and the 10/100th place. How about this one? 20,007 and 9 10/100,000, 10,000s. And then we wanted to write the decimal form of the following: 2003, 2003.79,079, 75,700 millions. So you write 75,000, and you make sure the last 0 is in the millions place. Okay? So you have 2003 and 75,007 in the 10,100,000, 10,100,000 millions place. Write a decimal in a position, write a decimal which has a 1 in the 100th place, 100, not hundreds, a 2 in the 10,000th place with the TH, a 3 in the million place, not millions, 4 in the 10 millionth place, 5 in the 10th place, and a 0 in the other places. So you come up with 3,000.5002004. That was probably a little bit quick. Sorry about that. 1 in the 100th place, 2 in the 10,000th place, 3 in the million place, 4 in the 10 millionth place, 5 in the 10th place, and a 0 everywhere else. Place a less than or greater than sign. The digits 174 are the same. You have no tenths, you have 1/10, that's the bigger number. Okay. You can put this on a number line: 174, 174.2, 172.1, 172.0, and the 174.0999 is a little bit to the left here. The 1 is a little bit to the right. Conversions between decimals and fractions or mixed numbers. 3 times 1/10 is 3/10, and this is 3/10. 4 and 24 thousandths. 4 and 24 thousandths, this way, which you can reduce to 4 and 3/125. This section is optional, so I'm going to forget about it. We wanted to do rounding. Round to the nearest hundredths. You circle the 7. All of the digits to the right are 0. The first drop digit is less than 5. That stays a 7. And then I show you how that goes on a number line. If you have your PDF, you can look at it quickly. Sorry, I'm rushed for time. Here's the technique. I just told you the technique. You circle like we had done before. You drop digits, drop all the digits, and so on. Other examples: round this number to the nearest hundredths, circle the first 7, drop the others. The first digit dropped is more than 5 or more, so the 7 gets bumped up to an 8. Round to the nearest hundredths. This is exactly in the middle. You go up to an 8. 32.000 is the result of rounding a number with 6 decimals to the nearest thousandths, 10 hundred thousandths, the 0. What is the largest such number? Well, you figure it out and you probably come out with the 0005, which is a little too, you circle this, you drop this digit, that gets bumped up, that's not it. How about 0.49? You circle this, all of these are zeros, first digit dropped is less than 5, that stays 000. So that's the number. Exercises. Now, I hope I have 2 more minutes. Write a 7-digit number which has a 7 in the 100th place, 700th place, 5, 10,000, 5, 10,000, 3 million, 2 in the 10th place, and 5 in the 1 place. So there are no decimals here, that's too bad. Write this number in words, again there are no decimals. Write the decimal form of 29,029, 29,029, and 62,005 millionths with the TH. So 29,029 and 62,005 millionths. Put the less than or greater than sign between 5.1 and 4.9. 5.1, 4.9. Round 3.249 to the nearest hundredth with the TH. Round 3.250 to the nearest hundredth with the TH. So 3.249, 3.250, 3.951 to the nearest hundredth again. And then 5.93 is the result of rounding a number with 4 digits, with 4 decimals, I mean. 1, 2, 3, 4. And you wanted to find what is the smallest number that you can round to that. Then you wanted to convert 0.2419 and so on to a rational number. That's optional. Okay? You don't have to do number 9. Okay, so I'm running something like 1 or 2 minutes over. I hope that's okay. See you next week. Let's do chapter 12, which is adding and subtracting decimals. The basics. We want to understand the concept of place value as a box. Remember originally we had box of 1, box of 10, box of 100, and so on. Now, you go to a department store, you buy items that cost $2.59. The second item, $5.21. The third item, $11.10. The sales tax amounts to $1.52. You have a $20 bill in your wallet. Can you pay for your items? If not, how much are you short? Or if yes, how much change will you get? Well, it's a practical problem. A word problem. Oh no, don't give me word problems, I can't do them. Get your feet wet. Do some, do more, do more. Practice makes perfect. Okay. How much do the items cost? This is a decimal point, not multiplication. There's too much space here. I couldn't help that. I wanted the decimal points by themselves. You want to line up the decimal points because then you add 1 to 1, 10 to 10, tenth with the TH to tenths, hundredths to hundredths with the TH. And when you add these numbers, you get 2.59 plus 5.21 plus 11.10, and 1.52. I know we should say 1 and 52 hundredths, but most people just read points. That should give us a 12, 2 carry 1. That should give us a 14, 14 carry 1. That should give us an 11 carry 1. So 1 and 1 is 2. The answer should be $20.42. It looks like you are 42 cents short. Too bad. So you walk out of the store, you return to your car, you ruffle through the cup holder because your spouse does not like loose change, so she usually throws loose change down. You find 3 dimes, 2 nickels, and 2 pennies. That should be exactly 3 dimes is 10 cents, 2 nickels, 5 times 2, 10, 40 cents, and 2 pennies, 42 cents. You got the 42 cents you were short. You return back to the store and you purchase your item. Then you bring him home to your spouse and say, thank you for always keeping loose change in the car. Okay. How do we add decimals? We've just done that. Note that we lined up the decimal points that guaranteed that we added hundreds to hundreds, tens to tens, and ones to ones. I don't think you need to look at this. So I'll go on. Oh, we have another problem, practical problem. Your checking balance today is $356.32 after you make a deposit of $125.46. So your balance today was less than that because after you add this, you have this number in your account. Yesterday, you wrote 2 checks, one for $33.62 and the other for $99.17. Okay. So one check for $33.62 and one for $98.17. And yesterday also, you deposited $203 exactly, $203.00. What was the balance in your account yesterday before any activity? Okay, so today it's $356.32 after you make a deposit of $125.46. Yesterday you wrote 2 checks for $33.62 and $98.17, and you deposited $203. Okay. Let this be the balance in your account yesterday before any activity. From that balance, you subtracted $33.62 and you also subtracted $98.17 because you wrote checks that was withdrawn. You made a deposit of $203, and today you also made a deposit of $125.46. So the activity in your check was, oh, this is what is left today after all this activity. So you deposited a total of $203.146, which is $328.46. You add the 2 positive numbers. You wrote checks for the amount of $33.62 and you wrote a check for $98.17. Add these 2. That is your debit. That is what comes out. I omitted the equal sign until I use this number. And let's reverse the operations. You have this much in your bank. You take away what you deposited. You added your checks. So yesterday you had $159.65 in your bank account. Okay. You subtract the deposits. You add the total of the checks. That's the reverse of what we are doing. So we arrive at $159.65. Why don't you take this number and then subtract $33.62 and subtract $98.17 from that, add $203, add $125.46. Do you get $356.32 back? Go ahead, see if it works. Example 2. A shaft is 2.1375 centimeters in diameter. A new shaft is required with a size that could be a lowercase a of 0.085 centimeters larger. What is the new size of the shaft? Well, the new size is the old size, 2.1375, plus the increment, 0.085, which is 2.225, 2225. 2 and 2,225, 10,000, 10 thousandths. Although it's easier to say 2.2225. Don't write it that way. Just say it that way. You had $159.65 in the bank. Oh, that should be erased. That's a leftover from a previous line. Just drop it. Properties of addition. Addition is commutative. It doesn't matter whether you have decimals or not. The number 0 is called the identity for addition. We had seen that before. A number plus 0 is 0 plus that number, so 0 is the identity for addition. Commutative property. Commuting means traveling. It doesn't matter whether you have the first number first or the first number in second place. You can commute, you can travel the numbers. Again, it doesn't matter whether you have decimals or whole numbers. So a plus b is b plus a, where a is a real number. Whole number, decimal, fraction. Associated property, you can associate the 0.4 with a 0.3 or the 0.4 with a 0.5. Associate, group together, okay, associate. You have a buddy, 3 of you are buddies, and you two do a work, or you two do a work, it doesn't matter, the result is the same. All this should be familiar. So a plus b plus c, b is associated with a, b is associated with c. We had seen this for whole numbers, it still applies to decimals. Another example, an irregular pentagon. A pentagon has 5 sides. Has measures 12.5, 20.9, 18.3, 25.2, and 7.5. Okay, 12.5, 20.9, 18.3, 25.2, 7.5. What is the perimeter? Perimeter means how much fencing do you need? Well, you add all these numbers and you're supposed to get 84.4. 84.4 feet of fencing is needed. Okay. You can copy these numbers from the numbers I gave you above. And apparently you have 2 carries, a 2 and a 2. See if that checks out. Don't use a calculator. Only use a calculator you come attached to. Once you use a calculator, it's going to be very difficult to do things in your head. Okay. Jose had $60.80 left after paying $53.50 for car repairs. How much money did he have before the payment? Well, obviously this number plus that number, which apparently is $114.03. So 60.8 and 53.5. On Friday, $139.20 were the receipts from a movie. On Saturday, you had $194 more money than you took in on Friday. So how much money did you take in on Saturday? 139.2 plus 194, which apparently is $333.20. Okay, we have about 20 minutes left for one more chapter. Subtraction of decimals. Just line up the decimal point and do the subtraction like you're used to. You may have to borrow. That means you open one box and you find 10 of the next smaller one. You open one box of hundredths, with a TH, you find 10,000ths in there, 10,000ths with a TH. So we are used to borrowing. We want to subtract 74.8 minus 53.5. This goes fine. 5 from 8 is 3. This becomes 1. This becomes 2. No borrowing needed. But if we subtracted 74.1 from 53, if we subtracted, not from, if we subtracted 74.1 minus 53.5, take away 5 from 1, too bad. So make this a 3, make that an 11, and the answer should be a 6, except that this is not where I start. This open should be further out. No, this is 5 and 1. Oh, I'm subtracting, but that should be a 6. That looks like a misprint. That should be a 6 here. And I borrowed, so that 4 is a 3, that should be a 0, and that 2 should be a 1. Something doesn't look right here, because when I add these two, I should get the number on top. Okay. So this should be 5 plus 3, it's not 11. 3 plus 1 is 4, that's okay. 2 plus 5 is 7, that's okay. But because of the borrow here, this is not right. See if you can fix it. And then send me the answer. Okay. Oh, I've done it properly here. So if I subtract, I need to borrow. The 4 becomes a 10 over here. The 4 is a 3, and the borrow, which is a 10. So I got an 11. 5 from 11 is 6. 3 from 3 is 0. 2. This looks okay, 20.6. This, I tried to tell you something, and I don't quite see what I tried to do. Finally, subtract this from that. So you have 72.1 minus 53.5. I guess you borrow here, and you should get this answer. Quick check, this is 11. This is 11, 12. Yep, 11, 12. And this becomes 6. So that answer looks correct. Now the difference between these two numbers is 18.6. However, if we had said subtract 0.321 from 5, you write the 5 first, and you need to borrow 4 and then a 10. And then this 10, you make it a 9, you borrow, that's a 10, that's a 9, that's a 10. 1 from 10 will be 9. I'll show you step by step here. Okay, you're down to this point. And then 1 from 10, 2 from 9, 3 from 9, 4 from 4. 0 from 4. Okay. We want more examples. Ooh, I'm running a little bit short of time, I'm afraid. The regular price of a suit is $329. It is marked down by that much. How much money do you have to pay? $329 minus $79.99. Okay, $329 minus $79.99. And if I've done it correctly, that should be $250.01. Now the seating capacity in the Los Angeles Coliseum in 1925, around there, was 75.1 for 1,000. It's really 75,141, but I made the thousand the unit. And in recently, it has been 93.607 thousand. How many more seats are there in 2010 than there were in 1925? You do a subtraction. 83.507 minus 75.144. 83.507 minus 75.144. And I come up with 18.463. So 18,463 seats. Because 1,000, I multiply by 1,000, the decimal point moves 3 places to the right. And then we have something about the Eiffel Tower. You can read it when you get to it. I'm running out of time. Oh, and then we do estimating. Approximately what is 15.896 plus 6.699 plus 31.134? Approximately. Well, this is, it is exactly apparently this number, but the question said approximately. This is pretty close to 16. This is pretty close to 7. This is pretty close to 31. And this is pretty close to 4. So I come up with 58 as an estimate. The exact number was 57.251. Well, the estimate is pretty good. If this had been 572 and I expect 58, something is definitely wrong. Or if this was 5.7 and I expect 58, that is definitely wrong. But the 58 and 57.25, that's a ballpark figure. I don't see anything wrong with that. It may not be right, but I don't see anything wrong with it. Not at this point. Properties of subtraction. Subtraction is not commutative. Subtraction is not associative. Okay? And then we get to the exercises. Okay? An irregular hexagon has measures 3.5, 9.2, 7.3, 5.2, 64, and 81. How many feet of fencing do you need? I'll read the numbers again. 3.5, 9.2, 7.3, 5.2, 64, 81. Millie had $94.50 in her checking account after paying $53.50 for car repairs. How much money did she have before the payment? So 94.5 and 53.5. On Friday, the revenues were $239.20. On Saturday, they were $99.90 more. $239.20, $99.90. What were the receipts on Saturday? A regular suit costs $417. It is marked down $88.99. How much do you have to pay for it? $417, $88.99. The Los Angeles Coliseum, in an early year you had 105,000, and later you had 92.604 thousand more. How many seats did you have later? How many more seats did you have later? Eiffel Tower, forget. Grocery shopping, well, you go get it.